Hi everyone, welcome. Today we are at Reinforcement Learning 105, Reinforcement Fine-Tuning and RLHF, How Human Feedback Shapes Modern Language Models. Today we are moving to one of the most important topics connecting RL and modern AI systems, as suggested by the title. And this is essentially how models like ChatGPT are aligned. So far, we have been thinking about RL agents acting in environments, but today, the agent is a language model. Instead of actions like left or right, the action is generating tokens. So every word the model outputs is actually an action. LLMs can be treated as policies over text. Why fine-tuning? Pre-training teaches models to predict the next token, but predicting the next word doesn't mean the model is helpful. We care about things like helpfulness, safety, correctness, alignment, so we need another step, fine-tuning. Fine-tuning turns raw capability into useful behavior. Three stages. Modern LLM training has three stages. First, pre-training, learn the language. Second, supervised fine-tuning, imitate good answers. And third, reinforcement fine-tuning, optimize behavior. Today, we focus on the third stage. What is reinforcement fine-tuning? Reinforcement fine-tuning means we improve the model using rewards. The model generates some outputs, we score them, and update the model. So instead of copying examples, the model learns from feedback. RFT basically means fine-tuning using rewards. Now let's give a three-level view. At the beginner level, the model tries different answers and learns what works. At the engineering level, we sample responses, compute rewards, and then update. At the research level, we optimize expected reward while controlling distribution shift. Now let's give a brief intro into reinforcement learning from human feedback. RLHF uses human preference as a training signal. Instead of asking what is the next token, we ask which answer do humans prefer. What is the pipeline of RLHF? The pipeline is actually very simple. We generate responses, humans compare them, we train the reward model, and then we optimize the language model. So human preference becomes a reward signal. So then you ask, what would be the reward model? The reward model is actually very critical. It replaces humans at scale. Instead of asking humans forever, we train a model to imitate human judgment. And so now, prompt plus response will give a score. Now we can talk about preference modeling. Suppose humans prefer response YW over response YL. A common preference objective is as follows. We want to minimize the following expression, which is equivalent to maximizing the log of the sigmoid of the difference between R phi of YW minus R phi of YL. And so if humans prefer response A over response B, we want the model to score A higher. So the model learns relative preference, not absolute labels. So where does RL enter? The RL is brought into the picture as the language model is the policy, the prompt is the state, and the generated text is the action sequence. And the reward model gives the reward. We optimize the model to generate high reward responses. So now we can talk about the RLHF objective. We want to maximize reward, but there's a problem. If we only maximize reward, the model may cheat. So we add a KL constraint to keep it close to the origin model. And basically, it is formulated as follows. We try to maximizing the theta, but we penalize the model if it drifts too far from the reference model. Now, why KL divergence penalty? This is very important. Without KL, the model may exploit the reward model. With KL, we can keep the model stable. And this is what we call improved behavior, but do not drift too far. Now we can talk about proximal policy optimization for RLHF. We use PPO because it limits how much the model changes. And same idea as many lectures before, smart updates leads to stable learning. This is why PPO is widely used in RLHF. And we bring the formula back again, where RT theta is the probability of generating the next token, and AT is the advantage, and we clip the ratio to be between 1 minus epsilon and 1 plus epsilon. Now let's review actor critic again. Here we can view RLHF as actor critic, where actor is the language model and critic is the value model. And the reward model basically try to judge. And so actor generates, critic estimates, and reward model judges. Now let's give a brief code intuition, and we can look at the loop. We generate response, we compute reward, we compute advantage, and then we update. And it is exactly RL, just applied to text. So now we can compare reinforcement fine-tuning versus RLHF. So LSFT, the signal comes from demonstrations, and the goal is to imitate good answers. RLHF, basically, the signal comes from human preferences, and the goal is to align with human judgment. And RFT uses text task rewards, and the goal is to improve specific task performance. And different feedback signal will lead to different fine-tuning strategies. And same framework, different feedback. So why RLHF matters? Some things cannot be learned from next token predictions, such as helpfulness, reasoning, tone, instruction following, safety, reasoning preference, and conversational quality. And RLHF helps optimize what humans actually care about. So RLHF seems great, but there are also many limitations. For example, human preference data can be noisy, reward models may be imperfect, model may exploit reward model weakness, and RL training can be unstable and also expensive. And finally, alignment is not fully solved by RLHF alone, and meaning that RLHF is powerful, but it's not magic. And this is still an open problem. And so what are some modern alternatives and extensions? There are many of them. For example, direct preference optimization, group relative policy optimization, constitutional AI, reinforcement fine-tuning with verifiable rewards, and finally, tool use and agentic IO. The goal is to have simpler, cheaper, more stable alignment. And this is where the field is going to. And so let's summarize the key takeaways of this discussion. LLMs can be viewed as policies over tokens. RLHF uses human preference as a reward, and reward models approximate human judgment. And PPO optimizes the model while controlling policy drift. And finally, RFT extends this idea to task-specific reward signals. And so the key idea is that modern LLM alignment is reinforcement learning in disguise. Looking ahead, the future of RL plus LLMs is not just better models. It's better feedback, better rewards, better environments, and better evaluation. So basically, RLHF connect RL with human values, RFT connect reinforcement learning with task-specific improvement, and future LLM agents will likely require all the things that I talked about just a few seconds ago. And basically, the future is not just better models, it's better feedback. Thank you for listening.